Okay, so I'm finally live. The purpose of this stream is to answer five of the questions surrounding data visa project as clearly as possible, as precise as possible, and with as much thought that can go into it. So let me begin by reading the first question out loud. What exactly is the prediction problem? It's a good question because it lets the audience know about whether it is a prediction problem or not at all. Okay. So the answer is that yes, a predictive model is being used to not predict but diagnose the process to find out where can or might the efficiency lie. And the way it's being done is that you have a predictive model of type classification. You use it to try to predict the TAT of cases with as much accuracy as possible. If you are able to get that kind of model, you can then use it to find out what properties of a case, what property, what properties of a case make them or drive them to a higher TAT bucket. It, it does not mean that I am saying that there are properties that are causing delay, but what we can identify is what are the possible drivers of delay. They can be the cause, or they can just be an effect of an actual cause, or they can just be coincidental. I have also got some sub questions. What is the target variable? The target variable for this case, and remember, it's not a prediction problem. Prediction is a subset of this problem. The main problem that we are, uh, the main objective that we are trying to achieve is to diagnose the process via different approaches, and one such approach is using machine learning model. I'll go through the sub question, which is what is the target variable? The target variable in this case is the TAT. That's what we're trying to reduce. What does question number 1.2? What does 51 days less than equal to 51 days versus greater than 51 days represent? Okay. So for the data visa cases, you get TAT as a number, as an integer, and we want to convert it into a classification problem. In order to do that, we bifurcate, not bifurcate, but we divide our TAT into several buckets, and those buckets then become classes, the target classes for the classification model to predict. And those buckets are depend on your approach towards solving this problem. I personally have chosen to segregate TAT into two categories. One is less than equal to 51 days, which means that any case whose stat is less than equal to 51 days gets the class 0, and all the cases with greater than 51 days get a class 1 representing greater than 51 TAT. Question number 1.3. Why is predicting this useful? The main idea is that If there is a model which is a mathematical representation of a real world process, and somehow if that model is able to correctly identify whether a case will be in any of these two buckets with a very high accuracy and with all the surrounding metrics also optimized, then that means that model has some information regarding the underlying structure of the process which is responsible in driving delay. And the way these models represent that underlying structure, or one such way that these models represent the underlying structure, is through the importances of the data data features which have been passed to the model. Because the model has used this data to be able to reach that prediction, therefore these features should hold certain information about tact, and it measures the importance via some metric for these features, and it gives me a list of the most important ones. If I look at the most important ones, I can say that these features, these data points, or these properties had a role in affecting the TAT for a case, whether in the downward direction or in the upward direction. In that sense, the predictions from these models are useful, but it's not our objective to use this model to predict the future for any incoming case. That's not the objective, though. It's only meant to be a diagnostic tool. That answers my entire first question. Question number two: what information is available at the moment of prediction? Okay. I have classified the information into three categories. One that is available when the case is defined, one that is available while the case goes on, and one that finally becomes available when the case ends. With these three in mind, we want to pick up only that information which is available during the case creation stage for modeling. But I would also argue that I can use all three types of information into the model, because my objective is not to build a predictive model which is going to be used for forecasting. I merely want to diagnose the existing process. And therefore, it should be okay for me to use the all these three informations into the model, because but what does a predictive model require? It would, for any incoming case, whatever I have used during training, I have to give it to the model for a future case. And for a future case, you would not have any information other than the ones that was created during case creation. And so you would not be able to use that predictive model. But if I use all three types of information to build a predictive model, all I want is what are the properties of the cases which in general have produced a significant positive effect on delay or a negative effect on the delay. What am I trying to say here? I have information about a case. Some of it is available during the creation phase, some of it is available while the case goes on, and some of it finally becomes available, for example, the TAT itself, once the case is completed. Now, if my objective was to build a predictive model, which once done will be used for forecasting the TAT for incoming future cases. In that scenario, I would not have the the present and the future information of I won't have the future information for a case for such cases, and therefore that information cannot go into that predictive model. However, if I'm just building a product predictive model for the sake of diagnosis, then it makes sense to use all possible kinds of information from the past, in the present, in the future with respect to that case, so that I could know that, for example, a set of activities which are ongoing and they are not, and the number of those activities is not predetermined, and that information goes into my predictive model, I could find out whether the total number of activities has any effect on the tap, which is an insight for them. And that sort of insight can be used to say that, hey, when you're trying to optimize this process for future, keep in mind that you would want to keep a certain type of activities or the frequency of certain type of activities very low or less than compared to this provided threshold. And that sort of insight is useful. So, diagnosis of a process and the process optimization can be done via predictive model by using all the information from the present to the future with respect to a case. So, I don't have to worry about what information is available at the moment of prediction. Okay, this answers my second question. What is the question number? What is question number three? What kinds of features exist in this project? Okay, let's let's start by describing what the data looks like. It's a table consisting of a unique reference ID to a case, properties of a case, and finally the DAT of the case. The properties of the case have varying structures. Some of them are single valued categorical columns, meaning that for each case, there's only one value provided for that feature. For example, something called as data visa global function name. Some some of those features are multi-valued categorical columns, meaning that for each case, that feature takes in multiple values. For example, countries involved, take countries involved as a feature. For a case, for a data visa case, there can be tens, if not hundreds, of countries that need to be involved in that case. And so it, and so not so, but that's it. That's it. That's what the structure is. That's what a multi-valued categorical column mean? It's a very interesting kind of feature structure which has multiple hierarchies provided to us within a single feature for each case. For example, since data visa case is all about data transfer, that data that data comes from a certain place, and the hierarchies provided point to the source, and therefore point to the source and the actual data from that source. And since we have multiple kinds of data requested, we have multiple hierarchies. That is that one structure. Others are your normal indicator columns which take value 0 or 1. Some of them are integer valued. For example, um, no, we don't have any integer valued column that would be required. Now these all these features can then later be binarized, meaning that each and every value of in each of these features for a case will be converted into a column, and they either take value 1 or 0, representing whether this value was present or absent for this case. And so each feature that we have created, which will go into modeling, represents that whether or not that value was present in that feature for that case, or in a more layman terms, if we consider, for example, a data category or a value called worker data. If that column is populated is 1, then that means that for this case, the worker data was requested. And then we are trying to find out whether it has any effect on the delay or not. That's what each of those feature represent. That's what each of these features represent about a case. That answers my third question. Question number 4. What is the current modeling pipeline? Okay. The current modeling pipeline is the current modeling pipeline starts from the place of data source. And so the first step is to get the data from GCP. The second step is to create any intermediate features that can be done without the help of Python. Secondly, all those features are binarized only by first looking at the structure of each of those features and then deciding on what way to binarize it. Later on, the third step is the feature selection step, where based on certain methods, we sequentially reduce the number of columns or get to a final set of features which will go into the model. We then train the model, and then we test it on unseen data, get the classification report, the sharp plot, and the final accuracy of the model, as well as the important features for that model. This is the existing pipeline. Okay, if I had to explain it to someone who's not technical, okay, The first step is to get the data from BigQuery. The second step is to make the second step is to transform it into something that is acceptable by the model. The third step is, since we have a lot of components in the data, potentially thousands of variables, it would not make sense to use all of them due to certain reasons based on modeling theory and actionability. So we try to reduce the number of variables that should go into the model using various techniques. Then that selected set of data goes into the model. Model tries to learn the underlying structure from the data, and later on, it tests itself by predicting the tag classes on the unseen data. And with that, we record its performance both on training data as well as testing data. We get all sorts of metrics that are possible for a classification model, and we try to judge how good this model is. If it's good or within the acceptable range, then we can extract the insights generated by the model and present it to stakeholders. That's what it means. I'll move on to question number 5. What are the biggest current limitations of the model? What are the biggest current limitations of the model? A sub question of that is, why has model performance plateaued? I remember that just using around 200 variables only out of 2000 plus, I was able to get 70% of accuracy compared to when I got the same accuracy after ingesting all 2000 plus variables. Reducing the features, reducing the features set or reducing the number of variables beyond this level only led to a decrease in model performance. That is one. Secondly, including the embeddings did not result in any improvement in the model. So, taking the features as it is and adding the embeddings, taking the features as it is, not as it is, taking the features in their binary form with or without embeddings has plateaued the model performance. You can you can try n number of feature variable combinations and that would still be less than 70%. The model performance could have plateaued due to I I don't think it's a data limitation. I have been provided with as or all the possible properties or information for that case. So I don't think it's data limitation. I think it's more of a it's more of a feature limitation. The features that we created do not serve, do not provide any improvement. No, no, no. the model's performance is stuck at a certain level on that data despite using all the possible classification models with hyperparameter tuning and cross validation, which suggests that it's not limitation of models, it's not limitation of data, but the way I am introducing these variables into the model. And so the next logical step is to somehow transform the feature set into something that is even more dense, that has even more. So now I have to transform this feature set into something that has a higher signal density, that has a higher signal density with reduced variables. So I since I have not done that, I think that so I think the model performance has plateaued because we have not yet condensed our variables and increased the signal density of the data. So it's a feature engineering limitation. Target formulation limitation. One of the limitations is feature engineering. The other could very possibly be target formulation limitation, which means that the two classes that I have defined may be causing the performance to plateau because I have seen that choosing different separators for classes did lead to different model performances, which includes increasing the number of classes and which also includes defining thresholds in to separate the target into two buckets. And so there's a working theory that if you slide your TAT threshold, you could increase or decrease the model performance. It is possible. So the way that I look, so the steps that I think are necessary to increase the model performance further is to increase the signal density in the data and to test different formulations of target, meaning converting the TAT into multiple buckets or choosing different or sliding the threshold to divide the target into two buckets. Those two things can be tested together and that can increase the model performance. Okay, am going to end my stream here now. There are two things. I have identified that there are two limitations that are stopping my model from improving any further. One is that the signal density is not enough, and secondly, the way the target has been formulated, because they are both variable in nature, And I have seen that at least for target formulation, performance depends heavily on how you define it. And so, feature engineering and target formulation should be tested either together or separately, hopefully together, to see whether the model performance can be increased any further. The only problem that lies with, with choosing an optimal formulation is that whether or not it makes sense to the business. For example, I have chosen right now the threshold of 51 days because the average of all the cases belonging to TAT below 51 is close to 15, plus at this separation, the samples in both the buckets are roughly equal in size. That has been my approach to formulate the target, which makes sense to the business because the idea is that if you are able to reduce the or put a cap on the target for all the cases as 51, then according to the data, your average, first of all, would never reach 51 days. It would be between 15 and 51. And that range, according to me, is acceptable by the business. That is that if they go with the objective of capping the target at 51 days in their very first improvement, then they can think about reducing it even further. But I do see a question that in that case, why not be revolutionary and try to separate the target by 15? 15 leads to that same problem that the samples in both the buckets would be skewed, that their proportions will be skewed, which is not good for the model, which is not good for the model. But it is something to think about. Currently, I'm working on feature engineering. My focus is not on target formulation right now because we already have a 70% accuracy in the model, which is actually good consisting considering how complex this process is, and that I was not expecting to achieve even 70%. So let's first try feature engineering and only then think about target formulation. With this, I can end the stream now.